Hello, just a quick update before I break all this down. I'm really excited. I'm going to go and see some people at Tesla Tech, and hopefully they can give me a hand with this. But yeah, uh, basically I've changed quite a bit. I've been working at this setup for about 7 months now. Seems like longer, but there we go. And I'm now using a bipolar toroidal Tesla coil. The secondary, it's wound uh, pretty much the same direction all the way around, but it's got a center tap, and I've got top loads here, which are actually it's a 5 nested spheres. The reason for the bipolar and the nested spheres is to create an AC capacitor, basically between the shells of the spheres. So one side of the bipolar is connected to the outer shell, and then the other side to an inner shell, and then the center tap to another one in between those. So the reason for this is to see if I can agitate the radial displacement field that forms inside the shell, in the cavity between the two capacitor shells, so that I can make it take a more circuitous route back to equalization. So I'm trying to create asymmetry in the system, and the way I'm doing that is I have inside here, I have two electrode rings. They've got 8 electrodes on each, and that's what these looms here are going to. There's one in the top hemisphere inside and one in the bottom hemisphere, and the switching system is basically applying high voltage DC from these 2 bricks here, but these only give out microamps, so I've had to create reservoirs. So the 2 bricks charge the 2 charge capacitors, and then those are then discharged through this resistor system here to control the current that's going through the switches. They're solid state relays, but they are limited to 1000 volts DC and 30 milliamps. So I've taken care of the current, and everything's working fine. The also alongside, that's the switching side is here. There's also a dumping circuit here as well for the electrodes before they get hit with the DC. And the reason for that is that the electrodes themselves inside the cavity get so highly charged with the displacement field that basically it takes quite a lot to affect the field that they're sitting in, because they're already part of it. So the idea is to dump the charge that's sitting on the electrodes, and those are then being dumped to the center tap of the system. And then the center tap from there runs in through the rectifiers. There's one for each polarity here, into a dump capacitor, a catch capacitor. And so the electrodes are the red wire going in, and the center tap is the other side of the rectifier. And those just go straight up to like 500-600 volts as soon as I switch the system on, before I even start switching, just from the center tap alone. So the outer rings here are for applying the axial displacement current. I've got 2 rods inside the bipolar secondary. It's an air core, and the 2 rods run in the center of that, and they have a cold output. It's that yellow wire there, and the other one's green, and a hot output, which is the front end. So I'm using the hot end to create what I hope is some kind of a field suppressor, or something to increase the pressure inside the system if it starts to rotate the way I want it to. And then the cold ones are going to the inner spheres I'm just experimenting with different setups at the moment. So I'm not pushing this hard. I'm not looking for corona. I'm just looking for a very solid field agitation, which I'm getting between the sphere top loads as an AC capacitor. And then the electrode rings are my attempt to create asymmetry within that capacitor, so that I force the system to resolve via a more circulatory route than it would normally take just to equalize immediately in place, like as does in a regular AC capacitor. So I'm switching. I'm using two teensies in here. There's one for each hemisphere so that they can run independently or locked or soft locked as it is. And that's the other side for the other hemisphere. And electrodes, and those are I've got them both on the same step. So each electrode receives its charge via this regulated stepping here, which is programmable. Everything's programmable, and so is the polarity of the rings. I've got a ton of variables that I have still to work through, but I'm getting there. But I am finding that if you see there, that's the resonant stuff. That's the two sides of the bipolar at the bottom. You'll see a disparity there because they're different capacitance levels, because the spheres are different surface areas. I've got a piezo in sitting actually on the outer sphere, and that's it's the magenta, and the top one that's a TLV chip. That's all coming from a sensor that's above the bipolar, which is going through being converted to a square wave so that I can maintain phase relationship with the system as well, because I can change the phase offsets as well for the different hemispheres. The electrodes on each hemisphere. So at the minute, so the spectrum analyzer is basically showing the side bands which are coming off the electrode pulsing. On the left there, I think I've got this 28,800 microseconds, which is 28.8 milliseconds per step. And so you multiply that by 8 to get the full rotation, and that gives you an effective RPM. I'm still working with low RPMs because the system seems to behave better at lower speeds. But here, what I'm seeing here is like a distinct ramp up, and this is polarity dependent. It changes with polarity and with direction, whether I'm rotating clockwise, counterclockwise on the top or the bottom, because everything is independent. So we're getting quite a solid ramp up with the side bands, and then a fast kind of shut off. It's almost as if that it's not time based. This is frequency based. But yeah, I'm still deciphering things and trying to really understand exactly what I'm seeing. But this is really my only kind of reference to see what is going on within the resonance structure of the whole system. And but it looks completely different if you take out the sequencing. All of that just turns into a solid peak for the resonance of the system. It's about 303 kilocycles at the minute. And aside from that, I've just got a AM radio, and you can actually hear the pulsing going on in there with a slight modulation on that from the two halves going in different directions. So anyway, I'll just run it with a good old ZVS and tuning it with one of the tuning capacitor boards. And I think that's about it for now. There have been many iterations, as you can see, of different switching systems, which were problematic. I really wanted to use the rod energy to switch onto the electrodes to see how the axial displacement current would work or blend or capture the radial displacement current in the cavity, but I couldn't get the switching system to work properly, and then there was so much spurious RF coming off the rods and the cavity itself. It was too difficult to really do, so I opted for just the plain DC to go in there. But again, early days. I've got a switching system which seems to work. Whether it's moving anything in the cavity, I can't tell. The idea is to get the DC polarity inside the cavity to offer a different route for the AC displacement. What's the word for it? I suppose to get somewhere else for it to resolve to more easily than just jittering around inside. So given a solid polarity, I was hoping that it would pull it towards it, and then as the sequence went around, then it would get pulled around the cavity in a certain direction to create some sort of a chiral or flow within the cavity itself. and then start applying differences to the electrode rings top and bottom to create an asymmetrical scenario, which is going to force it to resolve in a more circuitous route to actually come around and basically form a system-wide circulation that's in. So it's kind of like a solid state version of the Graviflyer or Titi Prosopel's device, which have both really inspired this. And yeah, so looking forward to seeing what Nathan and the boys think once I get to Tesla Tech. So I'm excited about that. Anyway, thanks for watching.